Well, what we end up with now, rewriting what we had a little more clearly. Remember, this is what we got from our T inverse matrix multiplied by our non-homogeneous part of our original equation. This is just the diagonal matrix you get from T inverse AT, and this is just what you get when you apply T inverse to TZ. Okay, well, this gives us two equations in Z1 and Z2. Ask everybody, figure out what are they. And if you don't know that at this point, you probably ought to sit down and figure out what the two equations are. Okay, well, the equations, first of all, we probably want to simplify this side. Okay? Olivia, you can just duck under them.
All right.
We don't mind seeing you anyway. Okay. Okay, so we simplify this equation by, first of all, just multiply this through the Z1, Z2. We're going to get just Z1, 5Z2. Z1, 5Z2. And then the first row is going to be just Z1. That's going to be added to this, so we get this. And the 5Z2 is going to be added to this. So if you just write it out and add these two matrices after multiplying this out, this is what you get. Well, why is that cause for joy? Well, we're going to see here very quickly. Z1 prime, then, is equal to this. So we get this equation. And Z2 prime is equal to this. We get this equation. Okay? Now, what is so wonderful about this is, as I say, again, reverting to formal mathematics language, ain't no Z2 in this one. Okay? In other words, this is an equation, a differential equation, just in Z1. And now, Z1 prime doesn't depend on Z1 and Z2. In our original equation, Y1 prime sure did depend on both Y1 and Y2, so that the Y1 and Y2 were all confused together. Now we've separated it out into an equation where Z1, our new variable, we have an equation just in Z1. And also, if you look at this equation carefully, you see that this is just linear first order, non-homogeneous with constant coefficients. Well, here's our Z2 prime, second row equal to second row, and that's also the same thing. Okay, so we just rearrange this, and we got Z1 prime minus Z1 equals this, and Z2 prime minus 5Z2 equals this. These are just simple linear equations, so we can use an integrating factor because that's something we learned very early and everybody seems to be pretty good with. Okay, well, that's really good. And you ought to be happy to see that because both these equations are easy to solve. Now, after you've solved them, remember that I said before, and I didn't get to say this in class, and this is kind of important. We solve, then, now this board's getting hard to write on, our y vector, remember, is T inverse times our z vector. So we can put our z solution, solution for Z1, solution for Z2 in a column and multiply it by T inverse, and we have our solution for the y vector. So that last step, then I didn't mention that, and I should have, is very simple. Okay? Very good.